Here we have another trigonometry question. And in this case, you'll notice that it doesn't tell you explicitly whether or not you're supposed to use sine law or cosine law or primary trig ratios. That's something that we need to figure out throughout the process. And there's also no diagram given. So based on the information in the question, we need to figure out what the diagram should look like. Probably going to be a triangle. But we also need to figure out, do we know any of the angles? Do we know any of the side length, and so on and so forth. So in this example, it says two cyclists leave from the same location. So let's say that they start off and they leave from that location right there, that black dot. That is where they're heading from. Okay, and so they're going to leave from that particular location. And there's an angle of 75 degrees between their paths. So let's say one goes this way and the other one goes that way. Okay, and so between their paths, we are told that this angle is 75 degrees. Okay. It says that Jeff cycles at a speed of 30 kilometers an hour and Janet at a speed of 36 kilometers an hour. So let's call the left-hand side here. Let's say this is Jeff, and over here this is going to be Janet. Okay, so one's heading in this direction and the other's heading in that direction. Okay, so they're biking away from each other. Okay. Jeff is biking at 30 kilometers per hour and Janet at 36 kilometers. How far apart are they after 4 hours? Okay, well, first off, we got to figure out the distances involved. Okay, because we're ultimately trying to figure out the length or the distance between the two of them after 4 hours. So let's say that this green line represents the distance between them after 4 hours. So we are looking for, there we go. We are looking for that distance. So we can figure out what that distance is going to be only if we know how far they've actually traveled after 4 hours. So Jeff is traveling 30 kilometers each hour. Okay, and he's been biking for 4 hours, so that means that he's moved 120 kilometers, which I gotta say is pretty good. Janet, on the other hand, is biking at an average speed of 36 kilometers, and she's also been biking for 4 kilometers. So in each hour, she's traveled 36 kilometers. She's been biking for 4 kilometers, so 36 times 4. She's managed to move 144 kilometers. Who knows? Maybe she went downhill. So Janet has moved 144 kilometers. Jeff has moved 120 kilometers. Who knows? Maybe he had an uphill climb, whatever. Okay, they've each traveled a different speed or a different distance. We want to know how far apart they are at the end. So what can we use to solve for this particular situation? We know it's a trig question. We don't know if there are any right angles. It doesn't tell us explicitly that there's a right angle in there, so we can't use a primary trig function. Next thing that we want to look for is, can we use the sine law? Okay, so do we have a complete side angle ratio? Okay, so we have two side lengths. We're missing that third side length. We only have one known angle. And it's not across from a side length that we know. So we cannot use the sine law. We don't have enough information to use sine law. So therefore, we have to see if we can use the cosine law. And we're looking for a length. And so we actually have a length. Okay, so this is a triangle. So let's label this as A, B, and C. Okay, well, we don't know the length of A, side A, that's what we're trying to figure out, but we do know angle A. Not only do we know angle A, we actually know the length of side B, and we know the length of side C. Okay, so what we have here is actually a scissor pattern. Okay, and because we have that, an angle that's contained on two sides, we can use the scissor pattern to solve this, and that means that we're going to end up using the cosine law for an unknown side length. And in this case, our unknown side length is A. So I'm going to take the formula for solving an unknown side length, and I'm going to write that out. So A squared is equal to B squared plus C squared minus 2 times B times C times the cos of A. Okay, and now I'm going to substitute in the values that I need. So I've got A squared is equal to B. Well, B is 120 kilometers squared plus C, and C is 144 kilometers squared minus 2 times 120 times 144 times the cos of 75 degrees. Okay, so these numbers are going to end up being pretty large. So I'm going to push off a little bit more to down and to the left. So A squared, okay, is going to equal 120 squared, which is going to be a very large number. Okay, so 14,400. Oops, sorry. Let me try that again. 120 squared. Oh, I was right. 14,400 plus 144 squared, which is 20,736 minus, I'm going to do, again, this whole piece is multiplication, so I'm going to do all of it in one go. Okay, so I'm going to do 2 times 120 times 144 times all times the cos of 75 degrees. Okay, and that's going to give me approximately 8,945. Okay, we'll round it there for simplicity's sake. So now I'm going to simplify this a little more. I've got 14,400 plus 20,736 minus 8,945. Okay, so that gives me a grand total of 26,100. 26,191. Now I got to get that A value all by itself. So I got A squared is equal to 26,191. Opposite operation of squaring something is square root. So I'm going to square root both of those. And that's going to mean that A is equal, and I'm going to do this to one decimal place. So it's equal to approximately 161.8. Okay, so that means that after 4 hours of biking, Jeff and Janet are approximately 161.8 kilometers away from each other, which I have to say is quite an accomplishment.